Okay, let's have a look at sketching, serious sketching of sine and cos trigonometric functions, where they could have been transformed, squashed, stretched, moved sideways, reflected, moved up or down, or anything that you like. So they've thrown everything, they've thrown the book at us. But never mind, we'll just step by step solve the problem and we'll get to the end. Now, the first, or we'll give you an example. We'll work with this example. It looks pretty horrible, doesn't it? I haven't actually got any reflections in that, but look, it doesn't really matter. There's enough there to worry about for now. So it's y equals 2 cos 2 open bracket x plus pi on 4 close bracket plus pi plus root 3, where x goes from minus pi to pi, if that wasn't enough. Now, we do have to follow a step-by-step approach, and we have to be very systematic about it to get to the end result. These can take like probably up to 20 minutes per question to get these right and do them properly, so they are long. Okay, the very first thing we're going to do is we're going to have a look at an overview of what they've done to this graph from the original graph of y equals cos x. Now there it is there, I'm writing it out for you, and we're just going to have a little bit of a peek and see what they did to it. Okay, I'm rewriting it in the way that I like to look at these things to more clearly identify what the transformations are. So we'll rub out the original. Okay, now that's the way I like to look at it. The dilation factors are always on the denominator. So there's a y stretch of a factor of 2, in other words from the x-axis, but it's still a y stretch. And there is an x stretch, if you like, it's of a factor of a half, and therefore that's from the y-axis. That's the dilations. Now, as I said, there's no reflections, but there are 2 translations. So what might they be? Yes, there's root 3 units up in the y direction and pi on 4 units to the left in the negative x direction. Now, let's rock and roll and get this sorted out. There's the function. The first thing I like to do is work out what I call the working domain, and that is not the domain of x, but the domain of the whole expression behind the trigonometric sign or symbol, such as in this case cos. So I've put a circle around it just to emphasize what I'm talking about. I want to know the boundaries of that expression so that I can easily capture my x-intercepts without calculating a whole lot of superfluous ones that are out of range, which I only find out about till the end. So when I've solved for x. So I'm working up towards it. I've got, therefore, x plus pi on 4 equals those 2 numbers, and therefore there's my end result. I've multiplied by 2. So that means I've got my working domain. I'm going to work from minus 3 pi on 2 to plus 5 pi on 2 to find out what my intercepts are. Okay, now what else have we got? We've got our working domain. The next thing I like to find out is where is my starting point for this graph? Because the original starting point, if you like, for the untransformed graph is at the origin when x is 0. So I want to see where did that point go to in this new transformed graph. So what I do is I just say, okay, we've got 2 times x plus pi on 4 equals 0, and I solve it for x. Okay? So that gets me, what does it get me? X is minus pi on 4. Great. Now all I've got to do now is get the y value for that starting point, and that can be achieved by substituting minus pi on 4 into the expression for the function. And here it comes. Okay, so it looks like it's 2 plus root 3. Now, we probably need to get a bit of an appreciation for what that number is in terms of a decimal approximation, because we need to know where it is on the y-axis for the sake of accuracy of drawing our graph. So we might as well get our calculator going and work that out. Aha, it looks like it's root 3 was 1.73, and therefore that starting y value is approximately 3.73. So that's a good thing to know. We can just sort of sock that away and use it when we need it. Okay, that's that bit done now, the starting point. Now we've got to do the amplitude and the range, and so that we can get a bit of an idea of the vertical sweep and boundaries vertically of where this graph goes. So there's the graph, and we're going to have a look at, oh yes, the amplitude is 2, so it goes up 2, down 2 from the central axis. So therefore the lowest value of y would be root 3 minus 2, because you've got to remember that the central axis now is that y is plus root 3, because that's how much we shifted it up by from the x-axis. Make sense? And I've done a decimal approximation of that as well, because we have to know where it is for sketching purposes. And the highest y value also, by the same procedure, gets us to plus 3.7. Well, that's pretty good now. We've got that sorted out. What's the next thing? We probably need to worry about intercepts pretty soon, I think. Now, let's see. Oh, this comes first, yeah. Okay, the period and the quarter cycle span. Alright, now, the period for this graph is, yeah, there's the number, that's the coefficient of the x term behind the cos symbol, and therefore the period is 2 pi over that number, okay, which is pi. Therefore, a quarter cycle x span is a quarter of that, which is pi and 4. Now, the reason I need to know that little bit of information is it helps me sketching the thing, because that the cos and the sine graphs can very neatly be split up into 4 little segments. Each of them go from, for example, from a high point to the central axis, or from the central axis to the low point, or from the low point back to the central axis, etc. And it really helps to work out how to sketch the thing when you actually do it in chunks of quarter cycles. Yeah, that's what I've written there for you. Yeah, okay, so we got that done. Alright, here comes the function again, and the next bit's coming. Oh, here we go, the intercepts. Now, because it's so long to work out the x-intercepts, and because I did it in a previous presentation, I'm actually not going through the whole catastrophe of working out the x-intercepts here. I'm just going to lay them on you. There they are. Okay, and then I'm going to calculate the y-intercept, of course, and that's where x equals 0. So that's an easy one, no problem with that. But we just plug x as 0 into the equation for y, and we get y as root 3. Well, now we're going pretty well into the whole thing. Now there's a few more things we have to work out. Not too many though, thank goodness. And the next thing is the end points. Now the end points are very important because we have to substitute in the end point values of x into the equation to work out what y is, because we have to label those on the graph. And there they are, just like magic. Now, oh yes, you can say that again, fuse, right? Aren't these things terrible? Now, I think all that's left for us to do now is to actually do the sketch of the thing. So, there we go, yes, draw the graph, start at the starting point, quarter cycle segments at a time, label all intercepts, end points, and alakazam, there it is. Now, see that little red circle I've got there? That is the starting point that I identified before. And what I would do, if I hadn't already got that graph organised, like sketched it, I would be doing exactly what I'm about to show you. I would mark off little vertical lines that I could rub out later of a quarter of a cycle in terms of an x progression from that point, and then I could rub them out later, but they're construction lines. So the first quarter cycle would go from that high point to the next value of x, which represents a quarter of a cycle on from there, and down to the next y significant place, which would be in this case the central axis. So here we go, voila. Then I work out where a quarter of a cycle is from there onwards, and that's going to intersect with the lower line. And incidentally, it's a really good idea just to sort of very faintly draw those three horizontal lines, the top of the graph, the middle axis, the central axis, and the bottom one, so you can kind of see what you're doing. You can rub them out later. That's the next construction line, and there's well, no, not construction line, just the sketching of the graph line, and there's and then so on and so on and so on until we get to the end point. Isn't that great? So now we're going to go backwards now, using the same procedure. There we go, and there we go, and there we go. That's the end. Now, all we've got to do now is make jolly sure we've got all our intercepts labelled as coordinate points, and that's our y-intercept, and our end points, and then what else? Oh, no, that's all. Okay, now, we've done it. My goodness, we've done it. But that would take you a good 20 minutes, or at least it did me when I was doing them, and I find that a bit aggravating, but anyway, that's what we have to do with these things, because they're very tedious. Now, oh, there he is. He's happy because we've finished. So what's he got to say to us? Truly beautiful. Ah, yes it is. How sweet it is. Okay, that's it from me. We'll see you next time. Bye for now.